We do computer modeling. We study 100% virtually how different materials and molecules that haven't been made yet can behave for technological applications. We study proteins, we study how electrons move in proteins, we study new superconducting materials. Everything is done 100% in a computer. So it's very, very powerful, and it's very, very useful because we really don't need to do the experiments before to get any useful information. With our models, we are able to compute or to predict how the electrons inside the molecules and the materials move and respond to light and to other stimuli. And with this, we can explain complex experimental results and explain complex experimental phenomena. The applications are multiple. For instance, we are working with proteins that if we succeed, they are going to be used to make devices that are completely compatible with human tissue. We're also trying to predict new superconducting materials that if we are successful can make it like an NMR machine, really, really, really small and really, really, really cheap. That could be a huge breakthrough for current technologies.